Hi, this is the lab report 3 for a magnetic field of a bar magnet by Dhruv Jain. Introduction. So the purpose of this experiment was to measure the distance dependence of a magnetic field due to a bar magnet and compare the experimental and theoretical values derived using the Biot-Savart law. This experiment also allows us to gain a better understanding of how magnetic fields work by making us use our smartphones, as it allowed us to get a better visual perspective of magnetic fields at work. The fundamental principles involved were mainly the Biot-Savart law, and the idea of how magnetic fields work is also essential to complete this lab, as we have to account for the Earth's magnetic north in this experiment. Here is my data from the experiment. The table on the left shows the data for the on-axis field. The table on the bottom shows the data for the off-axis field. And here is the graph for ln magnetic field, the component of x of magnetic field versus the distance ln r. And this equation plays a key role in calculations, as it allows us to get the dependence and also the value of mu in the experiment. Here are the calculations for the experiment. This is the equation from the graph as previously stated. The value of n, the distance dependence, is the slope of the graph, which is negative 3.1524. This equation can be further used to calculate mu. By rearranging the Biot-Savart law, we get e to the ln b equals mu naught over 4 pi times 2 mu over r cubed. Here e to the ln b is simply equal to b and r is 1 meter. So by inputting these values, we can calculate the value of mu, which comes out to be 1.946. The observations from this experiment were: when the phone was very far away from the magnet, an almost zero magnetic field was measured in the x direction in order to compensate for the magnetic north. As the phone started moving closer to the magnet, the x component can be seen increasing. For the magnetic field in the y direction, we have to subtract the y component of the magnetic field by Earth from the measured y value. Here is my code for the experiment. Firstly, I input my values for mu, which was 1.946, which I calculated from the experiment. Then I define this function def dipole to get the value of the magnetic field when given a mu and a r. This is the value for the formula for the magnetic field. Then I input the scale and the distance to make sure the computational model looks as aesthetic as possible, with the arrows not being big enough to be seen by the naked eye. Here are the observation locations that I inputted. Here's the continuation of the code. These are the magnitude and the magnetic field for each observation location. These are the first two are the magnetic fields on axis, and the last four are magnetic fields perpendicular to the axis. This code is to obtain the arrow, which is the magnetic field 45 degrees from the axis. Here we use the value of dperp, which was the average value of dperp from the experiment and can be seen in the data. Here is what the computational model looked like. The blue arrows represent the perpendicular magnetic field, the red arrows represent the on-axis magnetic field, and the green arrow represents the 45-degree magnetic field. The values for each arrow can be seen below. So the question one was, what if you hadn't oriented your experiment to compensate for the magnetic north? We have to compensate for the x component of the magnetic field of Earth. If we do not compensate for the magnetic north, then we get the sum of the x component of the magnetic field of the bar magnet and the Earth. By aligning it with the magnetic north, we make sure that measurement of the magnetometer starts from 0 Tesla. Question 2. What if you were to use two identical magnets stuck together end to end? The value of the magnetic field would be greater than just one magnet, but it may not necessarily be double. The relationship may not be linear. To conclude, the distance dependence came out to be n equals negative 3.1524 meter, and the value for mu came out to be 1.946. Biot-Savart law was the main principle involved in calculating these values.